Look at your hand. Whatever shade it is, whether you're pale enough to blend into a blank sheet of paper or dark enough to soak up sunlight like a solar panel, that color didn't appear by accident. It is the result of one of the longest, strangest, and most dramatic survival stories in human history. It wasn't random. It wasn't about beauty. And it certainly wasn't some cosmic roll of the dice. It was a slow-motion negotiation between your ancestors and the sun. A negotiation involving vitamin D, cancer, folate, Africa, ice ages, ancient farmers, and a giant nuclear star 93 million miles away that has been changing human bodies without caring what we think. If you trace your family tree back far enough, every single one of your ancestors, no matter where you're from today, had dark skin. Every one of them. Around 300,000 years ago, when Homo sapiens first appeared in Africa, light skin simply didn't exist. The entire human species was dark-skinned, which raises an obvious question. If all humans were originally dark-skinned, where did white skin come from? To answer that, we first need to understand what skin actually does. Most people think skin is just wrapping paper for your body. It isn't. It's your largest organ, constantly protecting you from the outside world. One of its most important jobs is defending you against ultraviolet radiation, UV light. UV rays damage DNA, create mutations, and over time can cause deadly skin cancers. Fortunately, your body has a built-in defense system called melanin. Melanin is basically nature's sunscreen. The more melanin your skin contains, the darker your skin becomes, and the more UV radiation it blocks. In equatorial Africa, where sunlight is incredibly intense all year round, this protection was essential. People with darker skin suffered less UV damage, stayed healthier, and were more likely to have children. Evolution rewarded dark skin generation after generation. But cancer wasn't the only reason. UV radiation also destroys folate, a form of vitamin B9 that is absolutely critical during early pregnancy. Without enough folate, babies can develop severe neural tube defects affecting the brain and spinal cord, or pregnancies may not survive at all. Melanin protected folate by blocking UV from reaching the bloodstream. So dark skin wasn't just preventing cancer, it was protecting future generations before they were even born. For hundreds of thousands of years, dark skin was one of humanity's greatest survival advantages. Then everything changed. Around 70,000 to 100,000 years ago, small groups of humans slowly began leaving Africa. No grand migration, just countless generations moving a little farther than the last. Eventually humans reached Europe, Northern Asia, and other regions where sunlight was completely different. The sun itself hadn't changed, but the angle of sunlight had. Farther from the equator, UV radiation is much weaker. Long winters, cloudy skies, and shorter days meant people were no longer drowning in sunlight. They were starving for it. And suddenly, the same dark skin that had saved lives in Africa became a disadvantage. Not because of cancer, not because of folate, because of vitamin D. Your body makes vitamin D only when UVB rays hit your skin. Think of your skin as a solar panel. Without enough sunlight, you can't produce enough vitamin D. Without vitamin D, your body struggles to absorb calcium. Bones become weak. Children develop rickets. Women's pelvic bones soften, making childbirth far more dangerous. In northern climates, this became a serious survival problem. Highly pigmented skin blocked too much of the already scarce UV light. People simply couldn't make enough vitamin D. Then, random mutations appeared. Some individuals naturally produced a little less melanin. Their lighter skin absorbed more sunlight. They made more vitamin D. They had stronger bones. Their children survived more often. And over thousands of generations, evolution slowly favored lighter and lighter skin. No one chose it. Nature simply changed the rules because the environment had changed. For years, scientists believed this happened gradually over hundreds of thousands of years. Ancient DNA revealed something far more surprising. Early Europeans were still relatively dark-skinned long after arriving in Europe. One famous example is Cheddar Man, who lived in Britain around 10,000 years ago. Genetic analysis suggests he likely had dark skin, dark curly hair, and blue eyes. The pale skin many people associate with Europe today became widespread only about 6,000 to 8,000 years ago. That's incredibly recent. So, what happened? The answer wasn't another ice age. It was farming. When humans stopped hunting and gathering and began growing crops, their diet changed dramatically. Hunter-gatherers ate fish, organ meats, and other foods naturally rich in vitamin D. Farmers relied mostly on grains. Their dietary vitamin D collapsed. Now they depended almost entirely on sunlight. Any mutation that allowed the skin to produce even a little more vitamin D became a huge advantage. Dense farming communities also allowed beneficial genes to spread much faster than before. Evolution hit the fast-forward button. Here's another fascinating twist. There isn't a single light skin gene. Skin color is controlled by dozens of genes working together. Even more incredible, Europeans and East Asians evolved lighter skin largely through different genetic mutations. Different populations, different genes. Same solution. Biologists call this convergent evolution. When evolution independently invents the same adaptation multiple times, it's usually because that adaptation is extremely useful. And while we're talking genetics, blue eyes are even younger. Every blue-eyed person alive today appears to share a common ancestor, carrying a single mutation that arose roughly 6,000 to 10,000 years ago. Before that mutation, every human had brown eyes. Think about that. Blue eyes are younger than agriculture, younger than Stonehenge. Traits we think of as ancient are actually very new. Now step back and look at the bigger picture. Skin color, the feature that has divided societies, justified prejudice, and shaped history for centuries, is, biologically speaking, nothing more than a UV calibration system, a built-in adjustment dial. Dark skin isn't primitive, it's the original human condition. Light skin isn't superior. It's simply an adaptation to environments with weaker sunlight. In Africa, dark skin was the perfect solution. In Northern Europe, lighter skin became the better solution. Neither is better. Both are brilliant answers to different environmental problems. The sun never picked favorites. It simply shined. Evolution handled the rest. Today, technology has changed the game. We have sunscreen, vitamin D supplements, fortified foods, modern medicine. We're no longer as dependent on skin color for survival as our ancestors were. But every shade of human skin still carries the record of an ancient journey that began under the African sun. Every color tells the story of where someone's ancestors lived, and every single shade exists because at one point in history, it helped people survive. In the end, every skin tone is simply humanity's answer to one question asked by the same indifferent star. How much sunlight do you need to survive?